Probably it's made of latex, but latex is pretty darn similar to rubber. So if I go ahead and if I take this, and I rub the face, what's the charge of that?
Negative.
This is negative. Now, I want you guys to watch and see what happens.
Okay.
And we're going to try to explain it.
Oh. Magic. Magic.
Okay, so what happened?
Magic.
What happened? They attracted. So let's see, I have a negative balloon, so the wall must be?
Positive.
Wow.
Wait.
What did I do to the wall?
You didn't do anything.
I didn't do anything.
The electrons from the wall ran away.
So I didn't do a single thing to the wall. So what is the net charge on the wall?
Neutral.
The wall is neutral.
Oh.
So this brings us to a whole new concept. And this is one that you need to diagram tonight. It says, come on. It says, explain the interaction between charge, balloon, and the wall. Well, we'll draw the picture in a little bit. But what is the charge on the balloon?
Negative.
Okay, negative. In what manner was the balloon charged?
Rubbed with fur.
By rubbing. What's the charge on the wall? The wall is neutral. So, by what manner, and we're going to explain what happens. This one has two pictures. This one is a little trickier to get in and to fit in the space. But the idea is we have a wall. Okay? The wall, it is important that you're going to draw in two layers. Okay? But there you look. Okay, so if this is, we'll say this is the outside, and this is the inside. Okay. We can say overall the wall is net neutral. Okay? And somewhere we're going to say far away. Okay, we have the balloon. And the balloon has a couple positives on it, but a lot of negatives. Now, can negatives move on the balloon?
Yes.
What material is the balloon made of?
Wait, no, you can't. It's
Plastic, so it's an insulator. So they can't move there. Can the this I'm gonna can they move on the wall?
Yes. Yeah.
What material is the wall?
Concrete.
Concrete, guess what? You can add concrete to your list of insulators. No, it cannot move on the wall. So you go, what the heck? I agree, what the heck? Well, the key thing is, what we're going to do, we're going to add one more layer of zooming in on this problem. I'm going to take these positive negatives, and I'm going to circle. Each circle is going to represent an atom. Okay? On average, atoms, most atoms, so my body is the positives. We know in the center of the atom is the nucleus. And on the outside is my electron field, my electron cloud, okay? And it's kind of moving around. So Javier over here, he is a negative. And my electron field, let's start really quick before we get to that. So right now, what side has more negatives?
Neither.
Neither. What side has more positives? Neither. We say there's no preference. But now, Javier would come over. I'm going to go over to him, but really the wall isn't moving. Javier is negative, okay? What are the electrons? Can the protons, can I move in the middle?
Yeah, of course.
Protons cannot move, Mr. Tracy. But what about the negatives over here? it's going to go whoosh. Okay? It's like a hula dancer sort of thing. It goes whoosh. Now, what is there more on this side? Positives on this side.
Negative.
So did the positives move?
No.
Never.
The negatives just went whoosh. So are we still standing according to our rule? Positives cannot move. All that's moving are the negatives, and the negatives move, Javier's the negative balloon, away from the balloon into the wall. However, can they run really, 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 really far into the wall?
No.
Can they flow through the wall? Why not?
It's an insulator.
The wall is an insulator, but within an atom, and we're talking tiny, 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 tiny scales, those electrons can go and move to the other side. What we call this process is called polarization.